towards the center. So friction force is responsible for providing the centripetal acceleration which is required for the object to move in a circle. So friction force will be equal to centripetal force, that is mv square by r. Now the value of friction force is mu n, where mu is the coefficient of friction, and n is the normal force. Since there is no motion in the vertical direction, the forces in vertical direction will be 0, the net force. So we have n minus mg is equal to 0, or n is equal to mg. So if we replace n with mg, we'll get mu mg is equal to mv square by r. M will cancel out, so v square is mu rg, or v is equal to root under mu rg. So for an object which is moving in a circular track and the track is having coefficient of friction mu and the radius of circular track is r, its velocity should be equal to under root mu rg. Now we'll see the case of smooth bank track. So suppose there is an object which is moving around a circular track of radius r, and the circular track is banked at an angle theta. So here what will happen is the vertical component of the reaction force m, this will balance the weight. So we have n cos theta is equal to mg, and the horizontal component will provide the necessary centripetal force. So n sin theta will be equal to mv square by r, where m is the mass of the object and v is the velocity at which it is traveling. So from equation 1 we have n is equal to mg by cos theta. So if we put this equation in if we put the value of n in the equation 2, we get mg by cos theta into sin theta is equal to mv square by r, or we can cancel out m. So v square by r will be equal to g tan theta, or v will be equal to root under rg tan theta. So if an object is traveling around a circular track which is banked at an angle theta, then its velocity will be given by root under rg tan theta. Now let's take the example of rotation of binary system. A binary system consists of two objects of mass capital M and small m, and these two objects move on circular orbits due to mutual force of attraction around an axis which passes through their common center of mass. Now let's say this with the help of an animation. So here we have a binary system having two objects, one with mass capital M and the other with mass small m. These two objects are being acted upon by a mutual force of attraction F. Because of this force of attraction, these two objects move around a circular orbit, with the center being the center of mass of this binary system, and the radius of the circular orbit for mass capital M is capital R, and for mass small m it is small r. So we can write the following equation. Since suppose this point is C, since C is the center of mass, it means that m into PC is equal to capital M into CQ. Now PC is nothing but the radius small r, so mr is equal to capital M, and CQ is nothing but the radius capital R. So this is one equation we get, and it's clear from the figure that r plus r is nothing but a, where a is the distance between the two objects, that is a is nothing but PQ. So from equation 1 and 2 we can write that r is equal to mr by small m. So if we put the value of small r in the equation 2, we get r into 1 plus m by m is equal to a, or r is equal to ma by m plus m. Similarly, we can get small r is equal to ma by m plus m. Now let's say this is equation 3 and this is equation 4. Now the value of the force which is acting on these two particles, F, will be equal to m omega 1 square small r for the object at P, and it will be equal to capital M omega 2 square into capital R for object at Q. Now since these two forces must be equal, so from here we get m omega square r is equal to capital M omega 2 square r, or now we can replace the value of small r and capital R. So m into small r, that is capital ma by m plus m into omega 1 square is equal to capital M into capital R, and capital R is ma by m plus m into omega 2 square. Now here we can cancel out these expressions, that is small m into capital M into a by m plus m. So from here we have omega 1 square is equal to omega 2 square. So this means that both the objects are moving with same angular velocity, and this is the reason that the distance between these two objects will always remain the same, that is the distance between these two objects will always remain a, where a is nothing but small r plus capital R. Now let's fix the frame of